Today we're looking at lesson 4.4 on parallel and perpendicular lines. First, we want to think about what parallel and perpendicular lines are, particularly with the slope. Parallel lines have the same slope. Perpendicular lines have opposite signs and reciprocal slopes, meaning if you started with, let's say, 2, the perpendicular slope would be negative and it would be 1 over 2. So you're flipping it, which is the reciprocal. So this would be the perpendicular slope. So we're asked here to write an equation in point-slope form for the line that passes through 4, negative 1, and is parallel to the graph of y equals 1/4 x plus 7. So what you need to figure out here is you need to figure out what the slope is going to be in your new equation. And that's what you're starting with. So the slope is the number next to the x when you have slope-intercept form. So in this case, slope for this equation is 1/4. If I'm writing an equation that's parallel to that, I'm going to use 1/4 for my slope. The point that they give me is 4, negative 1. So if I'm writing this in point-slope form, I'm going to take the point and the slope and put it in that form. So we have 4, negative 1. The slope is 1/4. So I'm going to use point-slope form. So y minus the y-coordinate. Since the y-coordinate is negative, it's going to end up being y minus a negative, or y plus 1, equals the slope, and then in parentheses x minus the x-coordinate, which would be 4. So this would be my final answer. Here we're asked to write an equation in slope-intercept form for the line that passes through 4, 7, and is perpendicular to the graph of y equals 2/3 x minus 1. So again, we're still looking for the slope first. The slope for this particular equation is 2/3. If I'm writing an equation that's perpendicular to it, I would need to flip it, or put the reciprocal, and since it's positive, the new slope is now going to be negative. So my perpendicular equation slope is y equals negative 3/2 x plus b. And to get the b value, we need to use the point they give us, 4, 7. So I'm going to plug in 7 for y, 4 for x, and I'm going to solve for b. So I get 7 equals negative 6 plus b. So b would be 13. If I put it all together in slope-intercept form, I'm going to have my perpendicular slope, which is negative 3/2, and then I'm going to plug in 13 for b. So my equation looks like this. Next, I'm asked to determine whether the graphs of 6x minus 2y equals negative 2, y equals 3x minus 4, and y equals 4 are parallel or perpendicular. So the first thing I need to do is make sure all of these are in slope-intercept form if possible. So this is already in slope-intercept form. This we can't make into slope-intercept form, but it's simplified as much as possible. But the first equation we need to change into slope-intercept form first. So 6x minus 2y equals negative 2. We need to move the x value away from the y so that y is by itself. So I subtract it. And then I have negative 2y equals negative 6x minus 2. so I need to get rid of the negative 2 by dividing everything by negative 2. So if I simplify that, I get y equals negative 6 over negative 2, or positive 3. So y equals 3x, and then I have negative 2 over negative 2, which simplifies to 1. So y equals 3x plus 1. So now I have all three equations in slope-intercept form. So I need to think about whether these are parallel, perpendicular, or neither. Well, you have a slope of 3 for both the first equation and the second equation, and then you have just a horizontal line going through 4 on the y-axis for the third equation. But since the third equation does not have a slope, I can say that these are neither parallel or perpendicular. If we're thinking of all three of them. If I want to be more specific, these two would be considered parallel. So all three in comparison are neither parallel nor perpendicular. And when you're thinking of just two at a time, the first two would be parallel because they have the same slope. Then we have the last problem, which is saying on the plans for a treehouse, so they're building a treehouse, you have a beam represented by a side which is labeled QR, and the endpoints of that are negative 6, 2 and negative 1, 8. Then you have a connecting beam, okay, so the beam is going to connect to the other beam, represented by ST, and their endpoints are negative 3, 6 and negative 8, 5. We need to figure out whether these beams are perpendicular. So again, we need to focus on just the slope. So I'm going to find the slope of QR by using the two endpoints, and then I'm going to find the slope of ST also by using the two endpoints and compare the slopes. So negative 6, 2 and negative 1, 8. This is for QR. To find slope, you have to subtract the y's over the x's. So I get negative 6 over negative 5, which simplifies to 6 over 5. So QR's slope is 6 over 5. Now I need to compare that to ST's slope. So ST has endpoints negative 3, 6 and negative 8, 5. I'm finding the slope for this one. Subtract the y's over the x's. So I get 1 over 5 for ST's slope. So if I compare, I have 1/5 and 6/5. These are not the same, and they're not reciprocals, and they're not opposites. So we can say that they are not perpendicular because of that. And that concludes lesson 4.4.